Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss necessary condition analysis using SmartPLS-4. What is a necessary condition? Let's try to understand. Researchers refer to expressions such as X is needed for Y, X is a precondition for Y, or Y requires X according to Dull 2020. Accordingly, the necessary condition is a constraint or a bottleneck or a critical factor. Any variable must satisfy the necessary condition to achieve a certain desired level of outcome. For example, you want to travel abroad. So the necessary condition is you should be having the passport. Other factors cannot compensate in such situation where a necessary condition is not satisfied. If you don't have the passport, other formalities will not work only. So if determinant X is a necessary condition for outcome Y will not be achieved if X is not satisfied or is it not in place. Necessary condition analysis is an approach and tool for identifying necessary conditions in data sets. A necessary condition is a critical factor of an outcome. If the outcome is not in place, the outcome will not occur. For example, a student will not be admitted to a PhD program when the GMAT score is too low. Creativity will not exist without the intelligence. AIDS will not develop without HIV, and organizational change will not occur without the management commitment. Such single conditions can be a bottleneck for the outcome. Layman examples. Ingredients are sufficient to make good food, but to switch on the oven is a necessary condition. Without the necessary cause, the outcome will not exist. A sufficient cause ensures that outcome exists, then only it will produce the outcome. So sufficient cause will check that is necessary cause satisfied, then only it will proceed further. A student who wants to be admitted to a US graduate school, the outcome needs to have a high score in the graduate record examinations GRE test. An adequate GRE score is necessary for the outcome. Necessary causes are not automatically sufficient. An adequate GRE score is not sufficient for admission because there are other factors for admission which play a crucial role, such as students' motivation letter, a good TOEFL score, reputations of the student's bachelor program, and the recommendation letter from the university. So, necessary causes are not automatically sufficient. Necessary conditions has been developed by Dull 2016. The starting point for identifying a necessary condition is a scatter plot of the data. Here we are not discussing sufficient condition, we are just discussing the necessary condition. So on the scatter plot, X displays the condition and Y gives the outcome. Each dot corresponds to one or more cases or observation. You can see here that the blue dots, when we pass a normal line through this, it is known as an OLS line. This one, OLS line. When we connect the dots, the outermost dots, with the help of vertical and the horizontal lines, and we create an envelope, this envelope is known as a sealing envelopment free disposable hull line. When we pass the line considering this envelope, it is known as sealing regression free disposable hull line, CRFDH and CEFDH. This I'll try to explain in the next slide. Let's see. We are having some scatter plots. We are having some scatter points. So we will connect the outermost points with the help of vertical and horizontal line. Vertical, horizontal, vertical, horizontal, vertical, horizontal, vertical. This way we will create the entire envelope. If I pass a line considering all these points, it is known as normal OLS line. And if I pass the line considering only these extreme points, the envelope points. So if I want to maintain the minimum level of Y, this one, the minimum level of X required is this much. So the black line represents the OLS line, blue is a sealing regression free disposable hull line. The red one is sealing envelopment free disposable hull line. Now, what is a bottleneck? Let us understand. This is the same thing which we have seen in the previous slide, and it is there in the paper written by Professor Richter, Professor Sandra, Professor Hoff, Professor Ringel, and Professor Sarstedt. If I want to achieve the minimum level of 7, the outcome, then the minimum level of X which is to be maintained is 5.5. You can see here, it's 5.5. So that's a bottleneck. The necessary condition outcome differs from the interpretation of linear regression, because in case of linear regression, we are passing line based on the considering all the scatter points, and therefore increase in X, that is the average increase in X, leads to an increase in Y. Now let us understand what is a ceiling accuracy. If I consider the blue line, that is a ceiling regression free disposable hull line, and all the points below it, all the points above it, all the points below it are represented by red circle, and above it are represented by green circle. So the ceiling accuracy represents the number of observations that are on or below the ceiling line, that's a red line, divided by the total number of observations, that is red and green. So points in a red circle divided by points in total, red plus green circle. So it is 90 divided by 100. If this value is more than 0.95, we will say that the ceiling accuracy has been achieved. There is no specific rule regarding the acceptable level of accuracy. However, the authors have suggested that any value which is above 0.95 is acceptable. The necessity effect size D and its statistical significance indicate whether a variable or a construct is a necessary condition or not. D is calculated by dividing the empty space called the ceiling zone by the entire area that can contain the observations called the scope. Thus, by definition, D can range from 0 to 1, but the author Dull has suggested that if you are having a value less than 0.1, we will say that this construct is having a small effect. If it's having a range between 0.1 to 0.3, it's a medium effect. If it is between 0.3 to 0.5, large effect. And if it is above 0.5, we will say it's a very large effect. It's possible that your model can consist of reflective as well as a formative construct. If you are having a reflective construct, then when you are carrying out a necessary condition analysis, you will only use latent variable scores. If you are having a formative score construct, then again you will have to ask the question that is my construct exogenous or endogenous. If it is exogenous, use the latent variable scores from the PLS-SAM, and the original indicator scores are also necessary. If your construct is endogenous, use the latent variable scores from PLS-SAM. Now, how to report the PLS-SAM results and NCA results in combination. If your PLS-SAM results are significant, so PLS-SAM results are significant and necessary condition analysis is also significant. What is the interpretation? Let us understand. You have got the admission, that is NCA, necessary condition analysis. You have got the admission in PhD program. But how you will perform, that is based on PLS-SAM results. So, what is the conclusion? On average, an increase in the exogenous construct will increase the outcome. Very good variable. However, a certain level of the exogenous construct is necessary for the outcome to manifest. It means that you will have to refer the bottleneck. The second possibility is significant determinant but not the necessary condition. So here this construct is significant, but the necessary condition analysis, the minimum threshold level is not necessary. So on an average, an increase in exogenous construct will increase the outcome. No minimum level of the construct is needed to ensure that the outcome will be manifested. You don't have to refer the bottleneck table. The third possibility is completely reverse. PLS-SAM results are non-significant, but it is a necessary condition. So a certain level of the exogenous construct is necessary for the outcome to manifest. It is just like you want to trigger the outcome. So if this is not there, the outcome will not be triggered. However, a further increase is not recommended. This construct which is necessary, but it is non-significant. It is only, you can say it can be only used for happening the event or happening the outcome, but further increase of this will not help you. That if you increase this variable, independent variable, if it is increased, your dependent variable is not going to increase. So what it is said, a further increase is not recommended as it will not increase the outcome any further. The procedures which have been laid, which have been given in this paper, specify the research objective and the theoretical background. Step 1. Step 2. Prepare and check the data. Make sure that the adequate sample size is there. Data distribution is to be reported. If any outliers are there, it means that if any observation is having a Z-score more than 3, it is considered an outlier and we will have to remove it according to the Sarsted and Mui 2019. Make sure that either you use a metric or quasi-metric data, that is an interval scale or a Likert scale. And another thing is, whatever the direction of the relationship is there, theoretically you should use the same relationship in the model. Step 3, run the PLS-SEM analysis. Step 4, ensure the reliability and the validity of the measurement model. The new features of SmartPLS-4 consist of that you can transfer this latent variable scores directly. In step 4, reliability and the validity of the model is tested with the help of composite ratio, Cronbach alpha, average variance extracted, Forner-Larkin criterion, and heterotet monotet ratio. Step 6, run the necessary condition analysis. Step 7, after this, evaluate the structural model and interpret the findings. Now, what is a bottleneck table? Let's try to understand. The bottleneck table will be generated for all the endogenous construct, that is a dependent variable. So, bottleneck adoption intention, bottleneck technology use. If I want 10% of adoption intention, and these are all my independent constructs: emotional value, ease of use, perceived usefulness, compatibility. So, if I want to achieve 50% of adoption intention, we will have to make sure that emotional value is set at 25 percentile, ease of use is at 20 percentile, perceived usefulness is at 9.3 percentile. Compatibility not available, or rather not necessary. Further increase, if I want to achieve the 80 percentile level, then we will have to make sure that this is at 49.6 percentage, 20 percentage, 15.7 percentage, 32.9 percentage. So for further increase of adoption intention, it is necessary that the compatibility construct is taken into the consideration. Technology use. Again, if I want to achieve 90% technology use, this should be at 49.6 percentile, 60.2 percentile, 66.2 percentile, 33.7 percentile, and 75 percentile. Now, how we will carry out necessary condition analysis? Let's see in SmartPLS. So for this, I'll activate the model. I'll request all my viewers to kindly refer my previous lectures so that you can understand the flow of this lecture series. Here, job satisfaction is affecting the staying intention of an employee. Environmental perception is affecting the staying intention of an employee. Organizational commitment is affecting the staying intention of an employee. Behavior of the co-workers is affecting the staying intention of an employee. The first thing which you should do is we'll have to run PLS-SEM and we'll have to check the reliability and the validity of the model. Start the calculation. Open report. We will first go in construct reliability and validity. We will see the values of Cronbach alpha. All the values are above 0.7. Quite good. Composite reliability more than 0.7. Threshold limit is 0.7. As all of them are in green, we have achieved the reliability. Moreover, average variance extracted of each construct is more than 0.5. This is also quite good. The same thing you can represent with the help of bar charts, and average variance extracted is also given in the bar chart. Now, to establish the discriminant validity, you should click here and directly go on the Forner-Larkin criteria. How to interpret this table? Let's understand. We will have to go diagonally 0.87, 0.836, 0.798, 0.813, 0.866. If I click on any outer values, this value should be maximum in the corresponding column and corresponding row. If it is maximum, discriminant validity is achieved. Similarly, if I talk about 0.798, corresponding column, it's maximum. Similarly, corresponding row, it is maximum. And therefore, we can say that we have achieved the discriminant validity. But it was found that there was some biasness in the Forner-Larkin criterion, and therefore, heterotrait monotrait ratio is a better measure for discriminant validity. So I'll click on HTMT. The limits which have been specified by the author is 0.85. All these values should be less than 0.85. If we are having these values less than 0.85, we have achieved the discriminant validity. Now, the new features of SmartPLS-4, I can directly create the new data file from here. If I want to include also the measured variables in my new data set, I'll keep this tick, and if I don't want, I'll remove this tick. So this is a latent variable scores which will save directly from here. Basically, latent variable score is a composite score for a single construct. So co-workers, single composite score, environmental perception, single composite score we will have for all the constructs. I'll rename this and I'll say this is, we are running necessary condition analysis. Create. Now I'll go back. So you can see necessary condition analysis is being, the data set has been generated. Now click on regression this time. Click on regression and save. The file name, you can keep any file name. I'll say it is NCA. Save. Select the data set from here and make sure it is a necessary condition analysis data set. So you can see all the LV scores have been generated. My staying intention is a dependent variable. So first I will drop this. As soon as I select this thing in the regression, the intercept is generated. Now what I'll have to do, I'll pick up all the independent variables, press Ctrl button for the multiple selections, and drag it and drop it in this box. Quite good. Double click on it. I'll remove the LV scores, apply. Environmental perception, apply. Job satisfaction, apply. I'll also change this one so that the better results are generated. Staying intention, apply. Now I'll go in calculate. The new features of SmartPLS-4 consist of regression analysis, logistic regression, necessary condition analysis, and NCA permutation. Let us try to run the first regression analysis. Start the calculation. Open the report, summary coefficients. You can see here, this is unstandardized coefficient and these are the p-values. If the p-values are more than 0.05, we will say that this particular latent score or this particular construct is insignificant. So you can see job satisfaction, its p-value is more than 0.05. And therefore, job satisfaction is insignificant, or rather it is not affecting the staying intention of an employee. Similarly, intercept value, p-value is also more than 0.05 and therefore intercept does not exist. We'll check the ANOVA for model to exist, or in other words, jointly, all these constructs are affecting staying intention of an employee. This is only possible if this p-value is less than 0.05. Here, It's less than 0.05, quite good, model exists. So you can get R square also from here and collinearity statistics also. That is, all these values should be less than 3. Fine. Let's go back, calculate necessary condition analysis. It will give you the minimum and maximum value of this, all the LV scores. Start the calculations. Click on open the report. You will get the ceiling line effect size overview. So this is the value CEFDH. So CE represents the envelope line and CR represents the regression line. Now let's click here and you will get the effect size. It's the same. See, this is the same figure which is there in the ceiling line. But are these effects significant or not? For that, we will have to run the NCA permutation. So these are the effect size. Then you can click on corner tables. So the co-workers and its effect on staying intention. Environmental perception and its effect on staying intention. Job satisfaction and its effect on staying intention. Organizational commitment and its effect on staying intention. CEFDH will give you the overall picture. So you can see if I want to achieve the level of 100%, the co-workers -1, environmental perception -0.783. Remember one thing, these are Z scores. Okay, these are Z scores. So for the better interpretation, we will go in the percentile. That will be much better. So job satisfaction -1.8 and organizational commitment 0.020. Click on percentiles. So what it says that to achieve the minimum level of 90% of staying intention, co-workers should be at 10 percentile, environmental perception should be at 12, job satisfaction should be at 3, and organizational commitment at 4. To achieve the 100% of the staying intention of an employee, it is very much necessary that the organizational commitment should be at 38.5 percentile. Job satisfaction is at 3.2 percentile and environmental perception is at 17.7. It is exactly same what we had done in this thing. That if I want to achieve 80% level of Y, what should be the minimum level of X? This is the same thing which we are trying to do. The same thing I can get it in NCA charts also. So this is a chart for co-worker. If I click on this, do I want the gray zone or not? I want the yellow line or not. So this is the regression line. This is the envelopment and these are the observations I'll get for each and every construct. Now I will have to run the NCA permutation to see that are the effects significant or not. So for this, I will again go back, edit, calculate, NCA permutation. Normally, this would be kept at 10,000, but for the learning purpose, we'll keep it at 5,000 to save the time. Start the calculation. Open report. Click on ceiling line effect oversize. Quite interesting results are there. Co-workers, the original effect size is 0.011. Environmental perception 0.289. Job satisfaction 0.033. Organizational commitment 0.156. I'll copy this to Excel. So I've copied this to Excel. Now let us try to see what are the threshold limits which have been suggested by the authors. See, this is a D value. So according to Dull, if your D is between 0 to 0.1, we are having a small effect. If it is between 0.1 to 0.3, medium effect. Between 0.3 to 0.5, large effect. And above 0.5, it is a very large effect. Fine. So we have copied this result of necessary condition analysis here. We will also have to run PLS-SEM according to this according to this structure, because we want to keep PLSM results first and then necessary condition analysis second. So let's go back and calculate. Again, go back. Yes. Activate the base model. Calculate. Bootstrapping. Start the calculations. Open the report. Take the path coefficients from here. Again, press copy to Excel. So I have copied the results of PLS-SEM. And let us refer this point again. PLS-SEM results significant. Necessary condition analysis is also significant. Let us see the first case. Co-workers to staying intention, p-value less than 0.05, significant. Here also it is significant. It means that we will have to refer the bottleneck table. And what is the conclusion? For co-workers, on average, an increase in the exogenous construct, which is co-worker, will definitely increase the outcome. That is a staying intention of an employee. However, a certain level of exogenous construct is necessary. We will have to refer the bottleneck tables. Okay, let's see for the next one. Here, environmental perception is significant, and here also the p-value is less than 0.05, significant. So here also the interpretation remains same. The interpretation is this one. On average, an increase in the exogenous construct will increase the outcome. Okay, let's talk about the third one. Job satisfaction to staying intention. PLSM results are significant, but this value is more than 0.05, so NCA has become insignificant. Now, what is our interpretation? We don't have to refer bottleneck table in case of job satisfaction. Let's see. See, on average, an increase in the exogenous construct will increase the outcome. No minimum level of the construct is needed to ensure that the outcome will manifest. Bottleneck table is not at all necessary. Okay, let's see for the fourth one. This is also less than 0.05 and this is also less than 0.05. Quite good. It means the first interpretation will come into the picture. But at any moment of time, let's say for example, if this value, I'm just giving you an example, if this value was more than 0.5, so it would be a third case. Third case in the sense that PLSM results are insignificant, but NCA is significant. It means that organizational commitment is a necessary condition to activate the staying intention of an employee. But if you go on increasing the organizational commitment of an employee, your staying intention of an employee are not going to increase further. It is necessary, but not sufficient. The entire procedure for carrying out the analysis is given in the paper when predictors of outcomes are necessary guidelines for the combined use of PLSM and NCA. You can refer the paper which has been written by Professor Nicole, Professor Sandra, Professor Hoff, Professor Ringel, Professor Sarstedt, and you can see the procedures which have been laid down. So this is what we had discussed about the hull line. NN is not necessary. NN here is not necessary, which they have used. It's the same thing which we had discussed. The combined use of NCA and PLSM. This is also there in the paper. The procedure is also given in the paper. Step 1, I will request all of you to, if you want to understand necessary condition analysis, please refer this paper. Then the scenario, what can be the 3 different scenarios which can exist? One example has been discussed on technological acceptance model and how to interpret it. And these are the graphs. These are the scatter plots which are there. And how to interpret the bottleneck tables, it is also given based on percentages. So this was all about necessary condition analysis using SmartPLS-4. You can Subscribe to my channel. You can refer my playlist in which I have already uploaded many videos of SmartPLS-4. Don't forget to press the like button. You can follow me on LinkedIn and Twitter.